everybody, my name is Lily and I will be your tour guide today for the Autotrophic Dream. Now watch your step as you climb aboard the Sunlight Mobile. Got it? Okay.
Oh my goodness, I'm so excited. This is my first microscopic tour.
Okay everyone, hold on, this might be a little bumpy. You bet! Our first stop is the cuticle.
Hey, what you think you're doing?
We're on a leaf tour. Don't mind Cuticle. He's very protective about his friends.
If you think you're gonna take all the water, then you're wrong.
I wasn't going to...
Oh, I see. You're oxygen.
No!
CO2, I'll get you.
Cuticle, calm down. We're just ordinary humans on a tour. You can let us by.
This time, Cuticle, out. Well, he was aggressive.
Don't mind Cuticle. He's very waxy. But don't worry, upper epidermis is much more chill.
What even?
Shh.
In with the sunlight. In. Stretch and prevent injury. Good. She seems very calm.
Yeah, she lets sunlight reach the mesophyll layer.
Whoa, watch out!
No, you can't leave.
Of course we can.
No, I'm Palisade mesophyll. I need to protect sunlight from leaving the cell.
We're not sunlight, we're just the Sunlight Mobile.
But photosynthesis needs to happen now so we can all get that energy. We need the sunlight.
You've got the wrong sunlight, but I want to see how photosynthesis happens.
Sure, I suppose. Just be careful. Don't mess anything up. Head over to the chloroplast. Carefully. Sorry about mesophyll. She's very rigid and tightly packed. Now off to the chloroplast.
Woo! What's the first step of our photosynthetic journey?
Well, we're passing the stroma now. That's where the Calvin cycle takes place.
Upon the earrings that you gave me, golden made of flowers dangling, and I almost.
The stroma is so fluid and free. Does anyone else see that elderly woman over there, or is that just me? Don't worry, I see it too.
Oh, that's Granum.
Grandma?
No, Ranum.
Oh. What is she holding?
Her thylakoid membrane stack of babies.
Thylakoid babies?
Yep, let's take a closer look. Okay, so let's take a look at how photosynthesis occurs within a chloroplast. Photosynthesis is the process by which plants take in water, sunlight, and carbon dioxide in order to make energy for themselves, glucose, and also the most important waste product in the world, oxygen. Now, it's not as simple as that. You may want to sit down. This is going to take a while. There are two main chemical reactions that take place during photosynthesis. The light-dependent reactions, which take place in the light, and the so-called dark reactions, or light-independent reactions, or the Calvin cycle. It is important to note that the dark reactions do not necessarily happen in the dark, but that they can happen with the presence of light or without it, unlike the light reactions, which only happen when there is light. So first, let's take a look at the light reactions. Light reactions take place within the thylakoid membranes, which are stacked into groups called grana. First of all, a photon of sunlight is absorbed by chlorophyll, a pigment which absorbs red and blue light and reflects green light. When the sunlight collides with the chlorophyll, an electron absorbs this energy and becomes excited. The very complicated job that the plant has now is to convert this energy into something that they can use. The first protein complex that is used within the light-dependent section of photosynthesis is photosystem II. So anyway, this electron within the chloroplast becomes extremely excited. So excited that it jumps onto a mobile electron carrier, which carries it along the electron transport system, which is basically a series of chemical reactions which take the energy from this electron and capture it so that the plant can use it. In response to the loss of the electron, the chloroplast splits the ultra-stable molecule of H2O, creating new electrons, releasing hydrogen ions, and of course, the oxygen that we breathe. This water-splitting process is called photolysis. The electron now travels down the electron transport system, and meanwhile, H+ ions are pumped into the thylakoid membrane, creating an H+ concentration gradient between the outside of the thylakoid membrane and the inside. The electron now reaches photosystem 1, where it waits until it is excited by another photon. Once this happens, the electron enters back into the electron transport system, completing the light reaction part of photosynthesis by converting NADP+ to NADPH. NADPH, much like ATP, serves as an energy carrier. The NADPH will now be used in the light-independent reactions. Is everyone following?
Yes, oh my gosh, this is so exciting!
I love learning about photosynthesis.
Can we learn more about NADPH?
Yeah, it's my favorite.
Okay, then let's get into it. Remember how I said that one of the reactants during photosynthesis is carbon dioxide? Well, that's where this comes in. A molecule of CO2 is absorbed into the cell and is combined with RuBP. RuBP is a 5-carbon sugar, and to start the Calvin cycle, it needs to become a 6-carbon sugar. So an enzyme called rubisco comes in and takes the carbon from the CO2 and bonds it with the RuBP to form a 6-carbon sugar. The 6-carbon now breaks down into 2 3-carbon sugars called 3-phosphoglycerate, or PGA. These PGAs will now go through the Calvin cycle while using NADPH and ATP, which eventually results in 2 G3Ps, or phosphoglyceraldehyde. The 2 G3Ps can form a sugar phosphate, which can turn into a sugar like glucose or fructose, which the plant can use for food and energy, or it can be converted into RuBP. And that, my friends, is photosynthesis. And everyone is happy because plants can get their energy, and we, as non-photosynthetic creatures, can get our oxygen. Ah!